Hi folks, welcome to our first day of notes for solving quadratic functions, working with quadratic functions. And actually this is a great way to start this unit because it builds completely off of last unit. So the first thing I'm going to talk about is we are going to find solutions for our quadratic equations. Okay, so a quick reminder that our quadratic equations is ax squared plus bx plus c. Okay, so this again is a quadratic trinomial, also known as a quadratic equation, quadratic function, as soon as we set it equal to 0. But we know it's a quadratic because it has the x squared. Again, this is standard form. Now, what we're going to be doing is we're going to find solutions for this. Our solutions are called roots, zeros, x-intercepts. Okay, so you have heard this before, way back when we started with functions, and I said find the zeros. The zeros were where it intersected the x-axis. So you will find that when we do graphing, so if this is my coordinate plane, a quadratic function creates a parabola. Ta-da, there's my parabola. Our solutions, our answers today when we are factoring are going to be where it intersects the x-axis. So typically we will have 2 solutions. Every once in a while we'll have 3, but we'll get to that when we get to that. And that's not a quadratic function anyway. So anyway, let's talk about the keys to success. So this is kind of like your steps for solving. So make sure that the polynomial is equal to 0. Okay, so then we're going to factor it completely. This again is all from last unit. And this is kind of the newer stuff where we're going to set each factor, each binomial equal to 0. Then we solve for the variable. And then, we'll check our answers, make sure it works. So we'll go ahead and start with our first example, and I'm going to show you 2 methods to do this. So first, we're going to make sure it's set equal to 0. It is. And then I'm going to solve this the way that you guys have factored x squared minus 9. The way that you have factored x squared minus 9 is by something called difference of squares, where we find the square root of each term. So that is x plus 3, x minus 3. We're going to drop down equal to 0. Okay, so we just completed step 2. Step 3, set each factor equal to 0. So that's setting each binomial equal to 0. And then we solve for x. So we'll subtract 3. We have x equals negative 3. We'll add 3. And x equals 3. And so my final answer, we're going to write this as x equals positive or negative 3. You don't have to write it this way, but I tend to write it this way, just so you know. Now this is the other method I'm going to show you. So this is kind of new. You only do it if you want to do it. So I'm just, again, showing you multiple methods. You do what works best for you. So this is actually called the square root method. You'll see what I mean here first. So I'm going to recopy x squared minus 9 equals 0. What I'm going to do, our goal is to solve for x. I'm going to add 9 to both sides. So now I'm left with x squared is equal to 9. And so again, my goal is to solve for x. I have x squared. This inverse of squaring is square root. 9 is a perfect square, so this works. I'm going to go ahead and find the square root of each side. So I have x is equal to positive or negative 3. I know it's positive or negative 3 because if I take 3 and I square it, I get 9. If I take negative 3 and I square it, I get 9. So again, when I check my work, this does work. Okay. Let's go ahead and move on to number A, not number 2. So for letter A, again, I'm going to make sure it's set equal to 0. It is. I'm going to go ahead and use difference of squares to solve this one. I have x minus 9, 7, still set equal to 0. We're going to have each binomial set that equal to 0. And solve for x. I have x equal to 7. And so for my final answer, there we go. All right. For number 2, Number 2, we have everything set equal to 0. We're going to, again, factor like we normally do. So when we factor like we normally do, I'm going to go ahead and start with my GCF. So we can't forget that we still have the GCF to think about. So I'm going to factor out a 2. Then I'm left with x squared minus 4 equal to 0. And when I have that, I can go ahead and do difference of squares. And then I can set each factor equal to 0. Whenever I have a GCF, I'm going to set my GCF equal to 0. And in this case, I find that 2 does not equal 0. Sometimes I have a variable, and we'll have that variable equal to 0. You'll kind of, as we do more of these, understand more of what I have going on. And I accidentally ran out of room. So again, we are just solving for x. I know I'm not saying much, but we are solving for x on these. And that's our goal. So really, if you can just remember, we factor like we normally do, and then we end up solving for x, you're good to go. Okay, so let's go ahead and take a look at C. C is a little bit different. With C, 10 is not a perfect square. Okay, so this is, remember I showed you at the very beginning this like new square root method. We're going to have to practice that because you're going to see one of our topics we are going to be doing a lot with square root. So going back to how I started that one, I'm going to go ahead and add 10 to both sides. So I have x squared is equal to 10. So with x squared equal to 10, I'm still going to solve for x. And I have it's x squared. The inverse of squared is to find the square root. So I have x is equal to, it's going to still be positive or negative, 10. Okay. Here's my answer. Okay. We will practice this again in class next time I see you. Okay. But again, I just wanted to throw that out. That, you can't always do difference of squares. Do it. You guys are comfortable with it, so do it when you know how. When it doesn't work, like when it's not a perfect square, we're going to apply this new method. Okay. For D, we're going to do the same thing where it's not going to be an easy difference of squares. Okay. We know it's not going to be easy difference of squares because it's plus right here. But I'm still going to go ahead and try and isolate x. So I'm going to subtract 4 from both sides. So I have x squared is equal to negative 4. If I try and find the square root, I find that this number does not exist. Okay, I'm going to take a swig of my coffee here real quick. And so this is an example of a imaginary number. So right now for Algebra 1, all you need to know is that this is our answer. It does not exist because you cannot find the square root of a negative number when the negative is underneath the radical. In Algebra 2, they're going to call this an imaginary number, also known as a lowercase I. Okay, but you can have fun with that in Algebra 2. All right, example number 2. So example number 2, again, we're going to start with factoring, finding the GCF. So for this one, I'm going to go ahead and factor out an x. Then I'm left with x squared minus 36, still equal to 0. Then we're going to keep factoring, so I have x plus 6, x minus 6, still equal to 0. From here, we're going to set each factor equal to 0. So even my GCF, so I have x equal to 0, x plus 6 equal to 0, x minus 6 equal to 0. And rather than running in below, I'm going to move up top. And I know I will be subtracting 6 and adding 6 to each side. I'm going to go ahead and write my answer up here. I have x equals 0, x equals negative 6, x equals positive 6. The other way that you might see these kinds of answers is written as something called a solution set. And it's kind of with a very capital S equal to, we do a curvy bracket, and then it's in numerical order. So again, you will sometimes see the solutions written in this way. This actually is not a quadratic function. We know it's not a quadratic function. It's a cubic function because it's x to the third power. Okay, so there you go. Let's flip it over. We'll do A and B next time I see you guys. Over here on the back, just a reminder with this first example that our goal before we attempt any of these problems is to make sure that it is in standard form set equal to 0. So it is quadratic standard form. So another reminder, it is ax squared plus bx plus c equal to 0. A, b, and c are coefficients, are numbers. If you glance at all the problems here, you see that they're not all set equal to 0. And so again, that's going to be kind of a new step to make sure we're doing that. Let's go ahead and just get started with this first example on number 3. And go ahead and factor and then solve for A. We know we're going to have 2 answers for A because it is A squared. So right here, I have a 1 for my coefficient. So when A equals 1, we're going to remember factors of negative 24 that add to negative 5. And it is going to be negative 8, positive 3, drop down equal to 0. Then we set each binomial, each factor equal to 0. And then we solve for A. And so I have 2 answers. There you have it. Okay, let's go ahead and try part A. Part A, again, the new first step is making sure this quadratic function is set equal to 0. So I'm going to subtract 45 on both sides. So I have y squared minus 4y minus 45 equal to 0. Now I can go ahead and factor. Again, my coefficient is 1, so I don't have to do the AC method. I can kind of jump ahead knowing that it's going to be y times y to get that y squared. Factors of negative 45, that would add to negative 4. It's going to be positive 5, negative 9. And then we go ahead, set each binomial, each factor equal to 0, and solve. Sorry, it looks like I'm not giving a lot of room to work this one out or these problems out, so don't write too big. Okay, B. So for B, the set equal to 0, but I remember from last unit, we got to check for GCF, and there is a GCF. So let's go ahead and factor out a 3 first. Now I have x squared minus 2x minus 8 equal to 0. Then I'm going to go ahead and factor. Okay, so I'm going to drop down that 3, and I know I'm going to have 2 binomials. I know it's going to be x and x because x times x is x squared. So factors of negative 8, that would add to negative 2. This is going to be negative 4 and positive 2. Now I set each factor equal to 0. So 3 equal to 0. Well, that doesn't work, so I'm just going to go ahead and say it does not equal. Then I have x minus 4 equals 0. X plus 2 equals 0. So as you get more of these, this is kind of a way to kind of keep everything organized. I have x equals 4 and subtract 2, and I have x equals negative 2. So my answers for B, I have 2 x-intercepts because, again, x equal, it's squared. Now for C, something to think about, we have x to the third power. So I should have 3 answers here. So 3 values that are equal to x. Okay, so 3 factors, 3 roots, 3 x-intercepts. This is a cubic function. The very first thing that we're going to do is we're going to go ahead and factor out our GCF now that we see that it is set equal to 0. So I'm going to go ahead and factor out an x. I'm left with 7x squared plus 2x minus 5 equal to 0. Now from here, my a does not equal 1. So I'm going to go ahead and do that AC method and solve it that way. Those of you that are comfortable with trial and error, keep doing it that way. So 7 times negative 5 is negative 35. Factors of negative 35 that would add to 2 is going to be positive 7 minus 5 equal to 2. And then what I'm going to do is I'm not going to forget about the GCF, but I'm not going to drop it down right now. So it's 7x squared plus 7x minus 5x minus 5. So I'm just dropping things down from what I factored. And now we're going to go ahead and do GCF factoring. And I'm running out of room, so I'm going to come up over here. And then I have 7x minus 5 times x plus 1 equal to 0. Can't forget about that GCF that I factored out first, so that's going to come out front. And then you set everything equal to 0. Okay, and go ahead and solve for x. So I have x equals 5/7, x equals 0, and x equals negative 1. Okay, and now d. d, I see that it is not set equal to 0, so that's my first step. So I'm going to go ahead and subtract 40 on each side. I have x squared plus 5x minus 36 equal to 0. This one, a equals 1, so I can go ahead and just factor, have x as the first term in each binomial. Factors of negative 36 that add to 5, that's going to be positive 9, negative 4. We set each factor equal to 0, and then solve. So my answers here, x equals negative 9 and x equals 4. You could see I have the bottom 4 circled. We'll do this together in class. You're more than welcome to try on your own if you feel comfortable with it. But just a quick reminder, what we're going to do, make sure each of the quadratic functions are set equal to 0. Then we're going to go ahead and factor like we did last unit. After we factor, we set each binomial equal to 0, each factor equal to 0, and solve for x. All right, that's it. I'll see you guys next time in class.